Okay. So we're finally getting to it. We're actually going to solve our equations now. Let me fix my camera here. Whoops. All right, so solving. So when you're doing quadratic equations, when we say the solutions, we want to know what values of x will make y equals 0. So sometimes you also see this as the zeros of a function. So most of the time, you have two solutions. So you have the vertex either below or above the line, and then it opens in such a way that it crosses your x-axis 2 times. Okay. If your vertex is on the x-axis, then you only have one solution, which makes it a lot easier to solve. And then sometimes your parabola never hits the x-axis. We say there are no solutions. Or in this case, for all these, it's real solutions, but we haven't gone over imaginary numbers yet. So we can just say no solutions at this point. Okay? All right, so we just have to actually do it. So it gives us our function, or an equation. It's not a function anymore. We want to graph it out and determine where are the solutions for this. So we start off the same way we did yesterday. So axis of symmetry we know is negative b over 2a. So if I substitute my values in, so I have negative 3, which is positive 3, over 2 times 1. So 2 times 1 is 2, 3 divided by 2 is 1.5, which is kind of a bummer. But we can say x equals 1.5. So there's our axis of symmetry between 1 and 2 here. So I can graph that. Okay. So what I'm going to do, since I don't really want to have to deal with decimals, I'm going to say for my x values, I want to check out 1. Where's my middle here? Let's do this. Let's do 1 and 2. So normally, if the vertex was a whole number, we would start with that one, put that one in the middle, pick some numbers smaller, some numbers bigger. But since we have a decimal, I'm going to say I'm going to pick one number immediately less than that and one immediately to the right of that, or greater. Okay? So I'm going to take those x values, I'm going to put it into my equation. So I'm going to start with 2. So I'm going to say, I want to do this. Make this work best. Let's put it down here. So let's say 2 squared minus 3 times 2 minus 4. Okay. So what does that equal? So 2 squared is 4, minus 6, minus 4 more. So 4 minus 6 is negative 2, minus 4 is negative 6. So when x is 2, y is, that was weird. Y is, I lost my pen. It just completely blew up on me. All right. Y is negative 6. So I can graph that to negative 6. Now instead of having to work it out, since we have an axis of symmetry, I went 1/2 unit over, right, to the right, and that's where this point is, 2, negative 6. So if I go 1/2 unit to the left, I would have the same value. So I know that when x is 1, y is also going to equal negative 6. Okay? If you don't believe me, you can do the math, but I got stuff to do today. All right, so I'm going to keep going. What about when x is 3? Same thing, so 3 squared minus 3 times 3 minus 4. So we have 9 minus 4 more is negative 4. So I can plot that point, 3, negative 4. So I'm getting closer. Remember, I'm trying to get to, I want my answer to be 0. Let me keep going. X is 4 now, so 4 squared minus 3 times 4 minus 4. So let's say that's 16 minus 12 minus 4 more. Look at that. There we go. That is 0. So there's one of my solutions, is at 4, 0, or just 4, depending on how they ask you. Okay? And then instead of having to work out the entire left-hand side, I know it's going to mirror the right side because I have my axis symmetry. So 0 is going to be -4, and -1 is going to be 0. So I can fill in these other numbers, so 0, -4, and -1, 0. So I can put all those together. If I can draw nicely, yeah, look at that. It's a pretty good looking parabola. Okay, so even though we didn't find the vertex, because if you look, I actually found the vertex somehow. It's like -6.25, which doesn't help us at all. So our other solutions to fill that in, because I sort of forgot that, it's -1, 0, or just -1. Okay, so it's the same thing we've been doing. We're still graphing it out. Only the key points we want to find today is instead of the vertex, we want to know what are these solutions? Where does our parabola cross the x-axis? Okay, so try them out. Take your equation, the function, put it on the graph, find where it crosses the x-axis. If you need help, let me know. Where's my button?